This is Alan Elliott with SAS Essentials, Mastering SAS for Data Analytics, 3rd edition. In this chapter, Chapter 3, Part 2, we're going to be continuing talking about reading, writing, and importing data. We've already covered many of the learning objectives for this chapter, and now we're going to be concentrating on how SAS data step reads and stores data. As we've mentioned in the past, if you want to follow along with the examples in this chapter, make sure you have all the data files downloaded and they're available at this website. So let's get started. Let's look at section 3.9, going deeper, understanding how the data step reads and stores data. So this section is about understanding how SAS works. And this is really helpful to you to be able to sort of look under the hood to see what's happening with those bits and bytes that SAS processes. It's a little bit like knowing how a motor in a car works. You don't necessarily have to know how the motor works, but actually you become a better driver. You're able to take care of your car and fix problems if you know a little bit about what's going on with your motor. You don't have to be a mechanic, but it helps to know what's going on inside and under the hood. So we're going to be talking about how SAS thinks. We're wanting to understand how the data step reads and stores data. And this includes the data step processing, the data step versus the proc step, reading data files, and reviewing how to read data into SAS. All right, so let's look at this example first. Now, this example, as you see, creates a data file called new, or data set, inputs ID as a character variable, age, and temp C. And since data is written in Celsius, we maybe want to convert it to Fahrenheit. So we use some code here within the data step to create a new variable called temp F, that is temp C times 9 divided by 5 plus 32. So that creates Fahrenheit. Then we have a couple of simple records right after the data line statement, and then we're going to proc print and run this. So it's a simple program, but knowing how SAS reads through this can be helpful in helping you know how to code in the future and how to diagnose problems. So here's an overview of the SAS data step. So when you run SAS, it goes into what's called a compile phase, where it looks at the syntax of the code. That is, does everything look right? Did you spell all the keywords correctly? Did you put the semicolons, all that sort of stuff? Then it goes into an execution phase. Well, if the compile phase says, hey, it looks okay, next it's going to go into the execution phase, where it actually reads the data, calculates or does other things within the data step, and then it goes to the output phase where it actually creates the data step. So all of these have to be done correctly before you get the results you want. So let's define a couple of these things. Compile means that SAS reads the syntax of your SAS program and looks to see if there's any errors. If there's no errors found, then SAS compiles the code. That is, it transforms the SAS code into the code internally used by SAS, and you don't need to know what that is. Then it goes to execution. If the syntax checks out, SAS begins performing the tasks specified in the code, particularly in the data step. For instance, the first line of this code is data new. So during the execution phase, SAS creates a blank data set with no data in it, named new, that it's going to be available now to put the data into that data set. And there's many other things that could happen within the execution phase. You could have many coded lines of calculations and other kinds of things, as we'll see later on in the book. And then finally, the output phase is where SAS reads in each data line, interprets the line of data, and then outputs it line by line until you have an entire data set. All right, so let's look again at this simple program. So again, SAS is going to check the syntax of the program. It identifies the type and length of each variable. So let's look at this. We have three variables, ID, which is character, age, and temp_c, which are both numeric. So it identifies these three variables. It says, okay, ID is going to be text variable, age is going to be numeric, and temp_c is going to be numeric. And it asks if any variable needs conversion. We'll talk about more about that later. But if everything is okay, it proceeds to the next step. However, if errors are discovered, SAS attempts to interpret what you mean. Sometimes SAS can go ahead and do, do the proceed with the data step, even if there might be a misspelling error or something like that. However, if SAS can't correct the error, it prints an error message to the log. And we'll see some examples of that. All right, so let's talk about what SAS does first. SAS creates what's called an input buffer. The input buffer contains data as it's read in. So here are the data lines, and we have two of them. So it reads the first data line, and it extracts it into what's called the input buffer. And that 1, 2, 3, 4, 5 to 12 is just giving you a column just to show you what it looks like. So there's actually 12 pieces of information. 0, 0, 0, 1, a blank, 2, 4, blank, 3, 7.3. So it's just reading that in and saying, okay, now I have some information in my input buffer. It also creates something called a program data vector, PDV, and it contains information about the variables. So first of all, there's two variables it creates on its own. One is called _n_. One means it's on the first record. _error_ currently is 0, which means it hasn't found any error. ID, notice ID is blank because it's a character variable. Age, currently, it hasn't read any data yet, so age is missing, temp_c is missing, and actually temp_f is missing also. So that's the program data vector. And what that is it's ready now to receive some data. So what happens from the buffer, so that's the first little picture up there, it reads the first piece of information, 0001, then it sees a blank, so that says, okay, that's the end of the first, we're in freeform format, so that's the end of the first piece of information, so I'm going to put that in ID because that's my first variable. Then it moves over and reads a 24, and it says, aha, this is a new piece of data, I'm going to put that in age because that's my second variable. And then finally, 37.3 reads that one in and puts it there. Now temp_f, which it has noted that there's something out there called temp_f, but there's nothing in it yet, so it just leaves that as a missing value until it processes the next line, which is this calculation, where temp_f equal temp_c, etc. Now once it does that calculation, then it comes up with an answer and puts the answer in the temp_f location. So this is sort of the process of SAS reading your data, putting it through the PDV, and then processing it to fill out all the information in the PDV. All right, now the output phase. So the values in the PDV are written to the output data set, which we call new, as the first observation. So once it fills out the PDV, the program data vector, it's going to say, okay, I've finished with everything I know how to do with this data, so I'm going to output it to the data set. And it outputs the information. Notice it's not outputting in or error. Those we can use later on within the data step. But for right now, it's just simply going to write out the information. And we see that the first record now has been written to the data set, ID, age, temp_c, and temp_f. Now it's going to go in and process the second data line. And it continues on. Now exceptions to missing in PDV, the initial values, as we notice, were dots, or which means missing. Some data values are not initially set to missing in the PDV. These are special cases, and we're going to learn more about them later, but they're variables in a retain statement, variables in a sum statement, data elements in a temporary array, and variables created with the options file or in file statements. We don't know what those are yet, but we'll learn about them later. All right, so do know the difference because, frankly, if you're trying to learn SAS to pass the basic exam, for instance, you need to know these terms, the input buffer, the program data vector, and what's going on with them. So it's not only a good idea to know it simply because to make you a better programmer, but if you want to progress in knowing SAS and becoming a professional programmer within SAS, passing the basic exam, you would need to know all of these things. All right, so once SAS is finished reading the first data record, it reads the second one, and it continues on until it runs out of records. So in this case, it reads the 2 records, it puts all of these in the data set, and then it stops reading in data. Now, so let's talk about descriptor information. So for the data set, SAS creates and maintains a description about each data set. This includes the data set attributes, variable attributes, the name of the data set, the member type, the date and time that the data set was created, the number, names, and so forth. So remember when we talked about the SAS7bdat file, this is all the stuff that's stored in that file. Once we create a data set, we create that file. All of these attributes and things, these descriptors, are stored in that file. All right, so let's look at this little program here. This program allows you to see all of that information that we just talked about. And it's called proc datasets. So it's a simple program, proc datasets, contents, data equal new. Now remember, we just created a data set called new. So what we're saying is we want you to show me the contents of data equal new. Now notice I have an alternative program there that you could also use. So when we run this program, it's going to give us this information. Notice here the first variable is named new. It's a member type data. The file size 5120. Last modified, in this case, 2020. I said the variable is named new. The data set is named new. All right, and then it continues on and tells us about more of the information within this data set. And I'm not going to go through all of this information, but as you can see there, lots of information. And finally, it's going to give us an alphabetic list of variables and attributes. So we see now we have age, ID, temp C, and temp F in alphabetical order, their type, and their length. All right, so let's take a look at how errors are found during the compilation. So we talked about how SAS goes through and compiles and executes the data, but what if there's an error somewhere in the program? So here's a program that we're going to use to illustrate some errors. All right, so in this original program, when we run it, we see that this is the data set we saw, and there's the output that it created. But what if we had an error in this program? For instance, notice here there's a missing semicolon after the 32. This is the end of a statement. There should be a semicolon. What this does is it causes SAS to not be able to figure out what's going on. It thinks the word data lines is a continuation of that line, and so it starts causing problems when it's trying to run this program. So if we tried to run that program, we can see that this is the typical error message that is going to be in the log. This is why it's important to look at the log once you've run a program, particularly for the first time, to see if there is a problem found. So it located the problem where it says data lines. Now, you can almost ignore all the rest of the stuff. Read the log from the top down, because oftentimes the first error it finds causes other errors as things go along. So we see it hits an error at data lines, and we can sort of back up and see, oh, I forgot to put a semicolon after the 32, and so you can correct that. All right, so a summary of during this compilation phase is that it's going to check your code syntax just as we saw there, and it's going to find out, oops, you messed up, you didn't put a semicolon in the right place. Identify the type and length of each variable, creates the input buffer, creates the program data vector, creates a descriptor information for the data set, and other options we haven't discovered. So that's what's going on during the compilation phase. Again, you just need to know sort of the process that's going on under the hood, because that's going to help you, as we see later on when we try to correct errors, that you know what's going on. The execution phase is an iterative phase. So it iterates through each data record. So as you can see here, line 2, each time the data statement executes, n is incremented by 1. So n is 1, so it's reading the first record, then n becomes 2, 3, 4, 5, as it goes on. Now then step 3, 4, 5, and 6, it's going to read that data, put it into the program data vector, and so forth. And then at 7, it returns to the top to item 2 and begins reading the next line in the data set. And it continues on until there are no more lines of data, and then it terminates. All right, so let's again look and see if we can figure out some errors in some programs, because you're going to need to learn how to locate an error in a program. And also SAS gives you visual indicators that something is going wrong here. So if we look at this program, we see in the data line, you know, the data has a sort of a yellowish background to it. But notice here our last line is not yellowed out like the rest of it. Now why is that? And the reason is because that semicolon on the last line is messing things up. It is an error because the semicolon should not be on a line with the data. It should be on a line after the data is finished. And so this is causing a problem. It's not going to read the data correctly because of that error. All right, here's another one. Let's look through this and see if you can find out maybe where things might be going wrong. Can you see this index error anywhere? Data lines. Now that looks like it should be there, but notice here we have an in-file statement. We're reading the data from an external file, and if you recall in a previous tutorial, we mentioned that almost always when you have an in-file statement, you don't have a data line statement. So SAS occasionally will be able to figure out how to correct simple errors like this, but in general, you wouldn't want that data line statement there because you don't have any data. You only need the data line statement if you actually have data. All right, here's another one. So carefully look through this or pause it for a moment, take a look at it and see if you can determine where there might be a problem with this one. All right, so, and this is a tricky one because sometimes we put too many semicolons in our code. And in this case, the in-file statement continues on the second line. So the in-file statement tells the name of the file coming in, but also the delimiter, which is a comma, first observation, and observation ending is 26. So it doesn't need that semicolon. That semicolon ends the statement, but we haven't ended the statement yet, so that would cause an error. Also, here's one where there's actually no particular error that you could see in this code, but there is a problem, and that is, as you might recall from earlier when we talked about the length of a character character variable is 8, and so when you have something like this, notice Rumpelstiltskin in particular is much longer than 8. So if you ran this, both Washington in this case and Rumpelstiltskin are truncated to 8 characters. So again, look at that. See how Washington, Rumpelstiltskin. So we can correct that. One way is to put a length statement in our data set before the input statement. So if we say length last $15, that says allow 15 characters for the last variable. We're going to see later on we can also use a format statement to do something similar. But once we do that, then we run the program and we see that it ran it correctly. So this is a fairly common error. So sometimes if you run a program, you see that maybe your text variables are being truncated. That would be one solution to that problem. Let's take a look at an example where we have missing data in the free-form data entry format. In this example, we're reading in a data set called names, and notice there are 3 records, George Washington, James Adams, and Bernie Rumpelstiltskin. However, there's a problem here because we notice that there is no age for James Adams and then nothing. And so this is going to cause a problem when we try to run this in SAS, because as we know in the freeform method, it tries to read the number of variables indicated in the input statement. And in this case, in James Adams, there's only 2, but it's looking for 3. And so when we run this program, we notice that it got to James Adams and nothing was where it was expected. And that actually caused SAS to stop. And we get this error message, SAS stopped because of errors. And it doesn't exactly tell us what the problem is, but we do know that it stopped and there was an error. And if we look at the output, we can see, oh, it stopped at this point. So we can go back and look and see within our data set maybe what's going wrong. It's a simple solution. We put a dot in that missing value area, and then when we run it again, then everything works out fine. Now let's take a look at missing data in the column kind of format. Here we have a data set that we're creating called My Data, and we've actually created 3 blank areas in this. If you open up the file called dcolumn.sas, what I did is I deleted the 80 from the first record, the 150 from the fourth record, and M from the third record, although I preserved columns, but I didn't move around any of the columns of the data. I also changed proc means to proc print at the end so that we could see the output of this program. The result is okay. It read it correctly. As we know, in the column method, blank values are okay as we read them in, so SAS was able to correctly read in this data set. All right, so once we've created a bunch of data sets, we have them now in our hard drive in libraries. And so if you go to the SAS environment in the left window and click on the libraries icon, you can see the libraries icon within the SAS environment. You'll see several libraries, including one called Work. Now, if you double click on Work, it brings up the contents of the Work library. And if you followed along the examples that we've done recently, you'll see that you have these 4 data sets, or maybe something slightly different. But hopefully you have the one called Employees. So we're going to double click on the one named Employees, and that allows us to see what's in that data set. So we click on it. It brings up the view table for work.employees, and here's the data that it created. So it's a good idea to look at a data set you've created just to verify that the information that you've read in is just as you suspected it would be. So go ahead and read in, use the view table to see the contents of a data set. Now, once you're finished looking at the view table, you can exit it by clicking on the small X at the upper right corner of the viewer. Don't click on the big one, that will close the entire program, but click on the small X to end the viewer. Okay, this ends this chapter. And in the next chapter, we're going to look at preparing data for analysis by adding some other important information to the data step that allows us to manipulate our data within that data step. So again, this is SAS Essentials. We appreciate you looking at this tutorial. Hopefully it was helpful. We appreciate you liking and subscribing to this channel. Thanks.